Welcome back, everyone. I am absolutely thrilled you're joining me today. If you're a focused learner looking to geek out on the absolute cutting edge of industrial networking, well, you're in exactly the right place. Today, we're doing a deep dive explainer on a piece of technology that is quietly revolutionizing how modern automated factories operate. We are looking at the IW-3240H Industrial Wi-Fi 7 Halow Gateway. Now, this isn't your average router sitting in your living room. This is pure industrial-grade muscle designed to solve one of the most expensive problems in manufacturing today.
Okay, let's dive right into this. Picture a massive, highly automated factory floor. You've got robotic arms spinning, autonomous vehicles just weaving through aisles, and smart sensors tracking everything in real time. Now ask yourself, what happens when a factory robot loses its Wi-Fi? Just for a second. In our homes, a drop connection means a buffering movie. Annoying, sure. But on a factory floor? A dropped connection means a multi-ton autonomous vehicle just stops dead in its tracks. It means production lines halt. It means complete chaos, and ultimately, a massive hit to revenue.
So, here's our roadmap for today's explainer. We're going to start with the high stakes. Then, we'll meet the IW-3240H itself. Part 3 covers its multi-LAN superpower. Part 4 details how it's built for the extremes, and we'll wrap the whole thing up with powering tomorrow.
All right, let's start with part 1, the high stakes of industrial Wi-Fi. Like I just mentioned, the environments we're talking about are incredibly unforgiving. In these automated factories, dropped wireless connections aren't just some pesky IT headache, they are a full-blown operational crisis. We are talking immediate, wildly expensive downtime for mission-critical automated guided vehicles, AGVs, and synchronized robots. A split-second drop can literally throw off an entire assembly line. And the fundamental problem with traditional Wi-Fi in factories is interference. You've got metal everywhere, moving parts, thick concrete walls creating dead zones. We need a network that is completely always on, no excuses.
Which brings us right to part 2. Meet the IW-3240H Gateway, the ultimate solution to our always-on problem.
Now, what's really interesting here is that this is a leading industrial edge Wi-Fi 7 gateway. But it's not just a standard gateway. It actually functions as an access point, a bridge, and a client. It's a remarkably versatile 4-in-1 device designed specifically to be the brain of a highly complex factory network. I mean, just looking at the array of antenna mounts and robust connectors gives you a pretty good sense of its serious capabilities. And it's built to physically fit right into these tough environments. It features a DIN rail mount alongside a really rugged aluminum case with wall mount options available too. That means it slots perfectly into existing industrial control cabinets. It's not meant to sit pretty on an office desk. It's bolted directly into the nerve centers of the factory floor, designed to vibrate, rattle, and roll with the machinery around it without ever dropping a single packet of data.
But that tough exterior is just the beginning. Let's move to part 3, multi-LAN, the failover superpower. This is the technological breakthrough that makes this device truly special. The absolute secret to this gateway's always-connected magic is something called multi-LAN. As defined here, multi-LAN is a proprietary technology that enables seamless failover between ultra-fast Wi-Fi 7 and long-range Wi-Fi Halow, which is known technically as 802.11ah. What does that actually mean? It means the device is broadcasting and managing two radically different types of Wi-Fi simultaneously. If one connection falters, the system instantly, and I mean seamlessly, falls over to the other. There's no interruption. The robot never stops moving.
Think of this dual network strategy like having a sports car and a tank at your disposal. On one side, Wi-Fi 7's are sports car. It operates on 2.4 and 5 GHz bands, with 4096 QAM support pushing a blistering physical rate of up to 6.3 gigabits per second. Huge bandwidth, incredibly low latency. But sports cars don't like rough terrain, right? That's where Wi-Fi Halow, the tank, comes in. Operating on the 900 MHz band with 64 QAM, it drops the speed down to 32 megabits per second, but man, it pushes through thick concrete walls and metal racks over long distances, completely ignoring the interference that would kill a standard Wi-Fi signal.
And this brilliantly illustrates it in action. You have your copper and fiber lines forming the hardwired backbone, but watch what happens to an AGV on the move. As it navigates the facility, the network provides completely seamless roaming. Say that sports car Wi-Fi 7 signal gets blocked by a giant metal shipping container. The failover recovery instantly kicks the connection right over to the 900 MHz Halow tank signal. The command center never loses sight of the robot, and the robot doesn't miss a beat. I really want to emphasize the range of that backup connection. 1 kilometer. Because Wi-Fi Halow operates in that sub-gigahertz 900 MHz band, its waves are longer.
They punch right through physical barriers that would instantly kill higher frequency bands. Giving your autonomous vehicles a safety net that stretches up to a full kilometer, that completely changes how you can design your factory layout.
Then on the flip side, when the path is clear, you are getting an absolutely monstrous 6.3 gigabits per second of throughput from the Wi-Fi 7 connection. This means your really complex machines, like advanced robots equipped with high-definition optical sensors, can stream massive amounts of data back to the server in real time with virtually zero latency.
So the wireless specs are incredible, but a sports car engine is useless if the chassis falls apart on the first bump. Let's head into part 4, built for the extremes.
This device is genuinely ruggedized. It boasts an operating temperature range from -40 to +70 degrees Celsius. For those of us using Fahrenheit, that is -40 up to roughly 158 degrees. So whether this gateway is sitting in a deep-freeze food storage facility or mounted right next to a literal industrial furnace, the connection remains totally stable. It simply does not care about the weather.
Plus, to actually support that 6.3 gigabit wireless throughput, the device itself has to be wired back to the main servers. To handle this, it's equipped with dual 10G Ethernet SFP+ ports. That ultra-fast wired backbone ensures that once the wireless data hits the gateway, there is absolutely zero bottleneck getting it back to your command center. It also integrates perfectly with legacy industrial equipment, which is so crucial. Look at this feature set. We've got an RS-485 to Modbus TCP gateway, allowing it to talk to older factory machines. It has digital input and dry contact relay outputs for basic signal control. It takes redundant power from 9.6 to 60 volts DC, meaning if one power supply fails, a backup immediately takes over. Throw in IP30 ingress protection and a super handy USB Type-C storage port, and you literally have a Swiss Army knife for industrial IoT. Now, you might be thinking deploying hundreds of these in a massive factory sounds like an IT nightmare. Not here. The IW-3040H utilizes proprietary zero-touch provisioning. That means your IT team can pre-configure the settings, and the second the gateway is plugged into the network, it automatically configures itself. Couple that with NMS, Network Management System support, and your central IT team can effortlessly monitor, configure, and manage a massive scale deployment from a single screen. So the really crucial point here is that this gateway doesn't just pass data along, it can actually think for itself. It features integrated support for Node-RED. For those unfamiliar, Node-RED is this brilliant visual programming tool for wiring together hardware devices, APIs, and online services. Because this runs natively right on the gateway, you can set up powerful edge computing workflows. You can program it to filter sensor data locally before sending it to the cloud to save bandwidth, or have it instantly trigger a relay outboot if a certain sensor threshold is met. It's smart, localized automation. We've seen the hardware, the software, and the incredible failover technology. Let's bring it all together in our final section, powering tomorrow's automated factory. Let's see how this builds the absolute foundation for the future of manufacturing. The IW-3240H is specifically positioned to enable cutting-edge industrial applications. We are talking about augmented reality glasses for remote maintenance, autonomous mobile robots, automated guided vehicles, and yes, even the rollout of humanoid robots working the factory floor. None of these technologies function properly on a spotty network. They absolutely rely on the high-availability, multi-LAN failover this gateway provides. Take AR glasses and monitoring tablets, for example. An engineer looking at a complex engine block through AR glasses needs extremely high-resolution 3D schematics overlaid onto their vision in real time. That requires massive bandwidth and super low latency, exactly what that 6.3 gigabit Wi-Fi 7 connection delivers. That engineer can walk the entire factory floor, fully immersed in their diagnostic tools, without ever experiencing a glitch or a dropped frame.
Which leaves us with a final thought to ponder. As the lines between sci-fi and industrial reality continue to blur, the machines we use are getting smarter, faster, and way more data hungry. We are stepping into an era of unprecedented automation. And the technology to keep it all seamlessly connected, like the Wi-Fi 7 and Halow synergy in the IW-3240H, is literally here today. So I leave you with this question. Is your factory network truly ready for the humanoid robot revolution? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.